file, which is basically some data. It is like name of the student. If you go up, you can look at the data. Look at the data. Wherever there's data.head, you'll see the first 5 rows of the data set. Right? So that's the data. Okay, actually, does someone else want to summarize what we did? Namrat, do you want to summarize what we've done from the start? First, we had this data set. Then yes, what did we do next? Yeah, it was a CSV file. Then yeah. Yeah, so basically what's the bigger picture? We're just trying to see what the data looks like. So the first few cells, we're just trying to see what the data looks like, where data.info tells us all the data types of the columns. Then there's, then what do we do next? Then we checked if there are any null values in the data set. Then we checked how many values are there using data.shape. Then can you go down? Then we checked if there are any duplicated values, right? So we kind of like just wanted to see what the data was like. Then we also we learned how to rename columns in a data set, right? Um, yeah. Then basically the next step was data visualization. So we plotted all the, if you look at the notebook, like you'll see we plotted all that data yeah, using different graphs, yeah, using Seaborn. Okay, and then so wait, this is the notebook we're supposed to open, right? So we plotted the data, yeah, data.drop. So we use different functions on the data, and we wait. Can you scroll down? Uh, I don't think there's a notebook for this. Can you just open an empty notebook? Or you can just share with him. Right. Okay, so we plotted all these graphs. Can you scroll down? And then we removed the extra column, which was extracurricular activities, which wasn't an integer. Then we plotted a correlation matrix, which is something like I'm not sure if I'll be able to explain it again. So it basically tells the how much each of these values are correlated to each other. So the stronger the correlation, the greater the number, and the closer it is to 1. So all of that where it's written 1, it means that the correlation is the strongest. And scroll down. Then we basically tried to train a linear regression model, which is what we were doing from the start. Okay, so model equals linear regression. We're just trying to call our model, and then we will fit it on our training data. Okay, so after this, I'm going to explain after this. Okay, model equals linear regression. Yeah, is that an issue? Okay, then sit down. Yeah. So after okay, we did something like this. Okay, today we're finishing up the project. So like, hopefully by the end of today, you will have like a working app of like this student performance prediction system, right? So the first thing you will do, this is the last thing you've done, right? Some of you. So this basically, do you know what linear regression is? Do you remember anything? Yes. It's a kind of algorithm that we use to predict linear relationships. So if our data looks like this, like when x increases, y also increases. If our data looks something like this, then we can draw a straight line and try to predict like new values. So this kind of algorithm is called linear regression. Okay, so we're basically using the linear regression algorithm, we're adding it to our variable model, and then we're fitting our model with this algorithm. So like our training data, what can you look at the last few cells and try to figure out what is our training data here? Training data is just 80% of our total data that we will use to train the model, and then 20% of it we will use to test the model. So what is the name of the variable that has our training data? Go upar. Okay, so we've used the train, test, split function to try to split the data set. So what is the variable that has the training data? It's, okay, let me just tell you, it's x underscore train. Can you see that now? We have an x underscore train, we have an x underscore test. This is our testing data. Then we have a y underscore train and a y underscore test. So these are the labels. For example, if we have number of hours studied, or we have extracurricular activities, or we have number of question papers practiced, right? So these are all the x values that we will use to try to predict the performance of the student, right? So this performance is the y value that we're trying to predict based on all of these x values. We're trying to predict this performance. So that's our y value. So y train basically has the yeah, the performance index of all these training samples. Okay, and y test has the performance index of all the testing samples. Okay, so this goes hand in hand, this goes hand in hand. Okay, so we have four variables now: x train, x test, y train, y test. Which of these will we fit our model to? X train, y. Because this is where we're trying to find the relationships in our data. This is the data that we're using to teach our model or our algorithm to learn how to predict. Okay, so we will use X train, and I think we'll also use. Can you slow down? Oh, so we'll also use Y train. Okay, does anyone remember what supervised learning was? Supervised learning. Okay, so supervised learning basically was when you gave the model some examples of data and then you also gave them the answers. So these are like your questions and these are the answers. And first we'll give the model both the questions and the answers so that it can learn. Or what does it look like? For example, if a student has 80% marks, what do his like our studied extracurriculars, question papers practice, what do they look like? Maybe students who have like 80% marks have like they've practiced like 5 question papers on average, or they don't have any extracurricular activities, or they sleep for 8 hours a day. So it'll try to understand the patterns in the data, and then it'll use patterns that it learns from this data to predict on this data, this testing data. So after we're done with the training part, then our model, which has the stored like numbers of like how to predict, this model has all the knowledge of how to predict now. Okay, so now we will use it to predict this, the X test. We'll just give it the X test data that is just like this much. We won't give it the performance index for this, and then we'll ask it to predict on its own. And then it has to basically predict this, and then we can compare with the model's predictions and y test to see how well it is, how accurate it is. Do you understand that? Okay, yeah. So are you able to understand, all of you? Like, I feel like it's not very clear. You can ask me again, I won't mind. There are just 5 kids, it won't take much time. Okay, ask me now, because then it'll be even harder and harder to like understand. Um, 1 second. Yeah. X test, Y test. So this, what we're trying to do is we're trying to give the model the testing data to see like how well it does. And this score function automatically, if we give it the actual labels, it compares the predicted labels with the actual labels to see how well our model has done. And then it gives a percentage, which is 98.9. So our model is 98.9% accurate on our data. Okay. Yeah. 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 Splitting the train test split. Yeah, linear regression. We've chosen linear regression. Training, yeah, training we did. Now we're doing testing. So model.score, and you basically give it the testing data and the testing labels. And then it gives you a score of how accurate your model is. If you guys haven't done this, just do this. Model.score. First, run all the cells. Run all the cells before writing any new code. And then try to write model.score, X test, and then Y test. Now there are certain other metrics we can use to model.score x underscore test comma y underscore test. There we can also use like, there are many more metrics that we can use to like try to evaluate how well our model has done. The most, okay, first we'll try to make predictions. For that, let's use, yeah, just one thing. Um, okay. Predict equals model.predict, which, yeah. Okay. Okay, try to print predict. What did you get? So you get an entire like column of just the predicted answers. Okay, try to do this. Print predict, and let me know what the rest of you also get. Then after that, in a new cell, let's try to visualize how far our predicted scores are from the actual scores. So then try to plot a scatter plot, plt.scatter. On one axis, we'll have the actual labels, so that's y test, and on one axis, we'll have the predicted labels, which is predict. Okay? Then do plt.show to kind of see what it looks like. Do you need help? This one, okay, you can open it on this one. Whenever you need help, just call me. I can help you. Uh, okay, so you're also supposed to import matplot. So before this, import matplotlib as PLT. Is it working? One second. Here's the code. Okay, so there's not much down. You can just copy from, okay. Okay. Or you'll have to copy some code from like min notes. Can you copy all the import statements from? One second. Yeah, 1 second. 1 second, coming. Import. Okay. Can you try to copy all of these statements? These statements, okay? These four. Yes. Matplotlib as PLT. Matplotlib has no. Oh, 1 second. It is PLT. Oh, sorry. Matplotlib.pyplot. Copy this. Yes. Okay, it's actually supposed to be matplotlib.pyplot. So, sorry. See, the thing with code is you don't have to remember like every sentence that you write. You just have to know how to look for an error and how to solve it and how to look for stuff on the internet. Import matplotlib.pyplot as PLT. Are you still getting that error? Print product. Model M is going to be small because look at the variable name. Your variable name is small m, right? That's why. And it's model dot predict. Model dot predict. There's no space in between. Just a full stop. And then predict, not product. Predict. Now try. Are you understanding what's happening? Are you sure? Okay. See, now you see, this is the graph. So on, okay, y test. Can you add a label to this graph? plt.x label, try. It's okay, it's okay. So on the x-axis is, I think, y test. Okay, on the x-axis we have the predicted values, and on the y-axis we have the actual values. So this is, we're trying to see how far off the predicted values are from the actual values. And you see it's not that far off. So our model is doing pretty good on the testing data, right? Yeah, try to run this. PRE, predict, model.predict PRE. Run this and like try to get the same graph. Yeah. Okay, must be the X. Oh, you've done X test, which has a lot of values. Now run. Now you see the graph. So this is the actual values and the predicted values. So like we're trying to see how far off they are, but you can see they're like pretty. Yeah, it's linear regression only, but you can see like how close they are, right? So there's not that much of a difference. So yeah, so it's a pretty good model on the test based on the testing data. R2 underscore score. Yeah. Now try to run this. Try to run all the cells from before also. Okay. After this, try to run all the cells from before. Yeah. Run. Yeah, yeah, yeah. Yeah, that's it. Then after that, we have to just make a model. So model equals linear regression from there. Okay. So now we know that our model is good. Now we're actually done with the linear regression. Now we're trying to make a web app. Remember during the orientation, I I like showed you an application sort of thing, like a link, and then you opened it, and then you could enter your extracurricular activities and stuff, and then it gave you a prediction, right? So now we're done with the back end, the model part of it. Now we're trying to implement that in a web app. Okay, for that you can't use Jupyter Notebook. You can't use Jupyter Notebook to make web apps. So that's why you're going to have to save your model and open it on Spider. Okay, I'll teach you how to do that. First, now, there are two things you can do. There are two options. So I've actually, like the saved model, I've actually added it to like all your devices. Either you can just directly use that, or you can also learn how to save the model. Which one do you want to do? So you can, so the saved model, the model file, I've already like added it to all your computers. So do you just want to copy that one to your code, or do you want to know how to save the file and get it to your code? Okay, so now you just need to open Spider. Do you know what Spider? Like if you open Anaconda, there's an application called Spider also, which you can launch. Yeah. Okay, so let me just model equals linear. Oh, sorry. Okay, so this is working. Anytime this is not working. Right now it's working. Now try the rest. Model.fit. The spelling extracurricular activities. Oh, in place equals false. The error extracurricular activity. Data drop in place equals false. Okay, okay, okay. So have you tried to open Spider? Open Anaconda, open Spider. Yeah, actually I need to try something. If you, okay, good. So our temp.py is directly in the same file as a model. Okay, so Model equals pickle dot load. Model equals pickle dot load. Hi. This is model dot pkl. I'll try to run this. File must read. D model dot pickle dot load. File must read and file path equals model dot pickle. Okay, never mind. Okay, so I hope all of you have opened Spider. Now you have to do a somewhat tricky thing. You have to save the file in the same directory as you have model.pickle and main.py. Okay. Now the way to do this is to try to save as. Look for the file and try to do save as model.fit x underscore train comma y underscore train. Yeah, so try to save the file. No, in Spider. So you have to open Spider now. Yeah, like this. Go to File on the top. It's over here. No, wait. Cancel this. Cancel this. Go to File over here. File. Now try to look for Save As. Save As. Now, no, wait. Yeah. Now try to locate which directory you want it to be. So for here, you have to go to your new volume, D. Okay, then go to workshop ML and then see here your temp is here. Okay, where's your model.pkl file? Okay, save. Yes, replace. Okay, so now it's in the same directory as your main.py. Also, another thing I want you to do is try to file, open main.py. Okay, now if you can you open main.py in your Spider? Sorry, cancel this, just cancel everything. Leave the opening the thing and whatever. Just try to do file, open, and try to look for main.py. New volume D will have it. Workshop ML, main.py, open. Okay, so this is the file. But just one thing, can you see if there's a model.pkl file? Or just in your file, no, you don't have to open it, just in your Finder. Go to your Finder or File Explorer. Okay, the thing is, one second, can I do it? Yeah, maximize. Yes. So can you go to your File Explorer? Yeah, File Explorer. And there's a model.pkl file, right? Okay, good. That's all we want. The model.pkl file. Now, can you just try to read through this file? Like some of the code you will not understand. For example, this just open the main.py. You don't have to open model.pkl. Sorry, I'm confusing you guys. Just open main.py and then just try to read through this file. So there are some comments, which is like where there are comments. This is stuff that you have to do on your own. But like I'm just going to lead you through how to do it. But this is like, so we're importing something called Streamlit. Okay, I'll just explain this on the board. And then this is how we're getting our model file. And then we'll write some functions to basically make the predictions. Okay. Now, you guys, okay. It's okay. We found a new way, which is easier. Open main.py, open. Okay. So you just work on this file now. Now just try to read through this file. Oh, so train test split hasn't been done. Okay, so you'll have to write like some more code. Do you just want to go to the Spider part? Or do you want to do this? Or we can do it at the end of the class, okay? For now, let's just assume that you've done everything else. And let's go to spider. Yeah, launch. Okay, uh, you don't have to write everything. I'll give you the code if you want to. Like I'll send it on WhatsApp because just read through it. And there are some comments. So everything that's not colored is a comment. It basically the computer doesn't execute that. This is just lines that I've written for you to read. Okay, and try to understand what the code is doing at every step. Okay. You can even like paste the code to chat GPT and ask it to explain what it's doing, like part of it or maybe the entire thing, but part of it mostly. Yeah, so now we're going to file, open. Yeah, so this is the code, just read through it, try to understand what it's doing. So you'll see that first of all, we're importing two things, right? What are those two libraries we're importing? Like we were importing Seaborn and we were importing pandas. There are two different things that we're importing now, right? What are those two libraries? Can anyone tell me? Sorry? Streamlit and Pickle. Yeah, yeah, that's right. So we have Streamlit and we have Pickle. So Streamlit is a library that we use to write web apps, to make Python apps, and it's very easy to use. If you want, on Google, you can search Streamlit documentation. Try, if you want, you can do that, and then it'll give you basically like how to create a Python app, okay, using Streamlit. But that's what we'll be doing too, so you don't have to open the documentation. Some of the code is already there. So Streamlit is the library that we'll use to create a web application that you can even share with others. For example, you'll get a link out of it, and then you can send it to your friends, send it on WhatsApp also. It'll work like on your phones also, right? So that's why we're using Streamlit. Then Pickle is the library that we use to deal with our model file. Okay, now model file, it's very complex. You can't even open it on your laptops. It's in a format, it's in a pickle format, right? So that's a format that we use to store all our machine learning models so that we can understand. So now if we want to understand this file, we'll have to call it using the pickle library. Okay, so that's why we've imported Streamlit and we've imported pickle. Now, next thing we're doing, the next block of code, you don't have to understand it. It's a try and catch block. I'll just explain it to you a little bit. So what it does is, it tries to get a file. It tries to get a model.pickle file. And if that doesn't work, it tells us that there's some problem. Because normally, like if I just wrote, oh, get the model file, then the model wouldn't, if there was an error, the model wouldn't be able to handle it and our entire app would shut down. But this way, the try and catch block, it doesn't let the whole app shut down. If the model file is not found, it'll just tell us that, oh, like the model is not able to load successfully, right? So that's important because otherwise our entire app would crash, right? This is just a good practice for when you're coding, but you don't have to understand it. Just understand that the try block is everything that the model will try to do. It will try to open the file, but if that doesn't work, it will give us an exception, or like it's not working. It will tell us what's not working. Yeah, yeah, exactly. Okay, if there's a file not found error, then it will tell us, oh, the file was not found. Or if the pickle is not working correctly, then it tell us there's some problem with the unpickling of the file. Then if there's another exception, then it will tell us, oh, another exception has occurred. So it's basically for us to know what the problem is, right? So you don't have to go through that a lot. You could have simply just done model equals pickle.load and you would have gotten the file. Okay, now move on to the next part, which is important. So you see a def, like a function that says predict student performance, right? Or something like this. And it's empty inside. Or there's just a pass block, which is just empty. So this function you have to write. Okay, so last class for all of you who weren't here, so we tried to write functions. Okay, so this is how you define a function. You write the def, this is a keyword, and then you write a name for your function. It could be any name according to what your function does. For example, our function will predict student performance, like it says. And then you write curly brackets open and close, and then you write a colon, okay? And then everything that's inside the function is basically indented. Okay, so there's a tab space. Tab space is like 4 spaces. You leave 4 spaces here before writing anything that's inside the function. Okay, now you guys will have to write a function that basically, yeah, that basically, do you remember arguments or parameters in a function? It's basically data that we give to the function in order for it to like do something inside. So we will give it the data like the hours studied, the question papers practiced, no, you can write any variable name. So it's also like a variable, so you can write any variable. And when we're calling that function, we'll give in that data, like that specific value, and it will basically make a prediction. But for now, you have to give it an empty parameter. Parameter is just a variable that you give. In place of that, when you call the function, you give the actual value, and then it's able to perform whatever operation you want to perform. Let me just give you an example. For example, if I want to add two numbers, if I want to create a function that can add any amount of numbers, right? So I'll just do def add, and then in brackets, I'll give the first number and the second number. But when I'm defining the function, when I'm writing the function, I'll just write a comma b. So these could be anything. These numbers could be anything, and it's up to us when we're calling the function. But for now, we know that when we get a and b, which could be anything, we have to add a and b, and we have to return the sum. So if, for example, if c equals a plus b, then we have to return c, right? Now, when I call the function, so there are two parts to a function, a definition and function calling. So I can call this function multiple times in a program with different values. For example, I could do add 2 comma 3. Like, for example, let me just give a name, result. Result equals add 2 comma 3. So our result value will be 5. Then again, I can use this function. I can do result 2 equals add 3 comma 3. So this will take, so A will take the value of 3 and B will take the value of 3, and our result 2 will be 6. Okay, so just like that, we're trying to define a function that takes in the value for hours, question paper, extracurricular activities, all the stuff that we had in our columns, and then it basically uses the model.predict function to predict using that all those values. Okay, so for now in the brackets you just have to give all the possible parameters, all the column names, right? But here you're giving them as variable names, so they can be named anything. For example, if your column was hours studied, right? If this was your column, then you can also name it hours. You can also name it A. It doesn't matter, it's up to you. And then whenever you have to perform something with that parameter, you have to use this same name. Okay, for example, if I want to take in the arguments, but now it always gives the arguments in string, like a user will always give the arguments in string, but I want to convert it to integer. So I'll just do a equals int a. Like I'll use the name that I gave inside, okay? But it's actually like it's really important to use names that mean something, right? A, you will simply forget what it was. So if it's R studied, maybe you can do R's. If it's question papers practiced, maybe you can do papers practiced, right? Shorten it, but make sure it means something to you, because otherwise you'll forget, okay? So for now, you just have to give the parameters. So this function will take hours, question papers practice, all that, give the parameters inside the brackets, separated by a comma, just write the variable name separated by a comma, and then try to convert them to integer, all of them, okay? And if you don't understand anything, call me. Also, variable names don't have any spaces in between them. For example, if you're doing hours, you can't do hours space studied. You have to do like either one word like hours, or you have to do hours underscore studied. Okay? Because variable names don't have spaces between them. Yes. Yeah. Just one thing, it will be helpful to kind of like give it in the same order, but you can do any order. But so when you're giving values, like for example, when I was doing the add thing, right? I was doing dot add and then a comma b. So always the first value will automatically go to a, and the second value would automatically go to b. So this ordering matters, okay? So if you're giving extracurricular activities first, then make sure then when you call the function, you also give the extracurricular activities first over there. Okay, I know this might be a little hard to do, but like this is what programming is, like doing stuff on your own. This is how you will learn. Are you able to do it? So just give the parameters separated by brackets. Yeah, very good. And then if you want, you can also like go to the Jupyter notebook and look at what all columns were there. Or like, let me just write them down for you. So we had hours, we had previous scores, we had extracurricular activities, we had number of hours the person sleeps, and we had question papers practiced. After you're done giving all the parameters, you have to like convert them to integers. You're not getting it? Okay. So remember last time we did how to create functions? Are you not getting the parameters? Okay, so all these are studied previous course. These are kind of like variables. So when we call this function, we use a dot predict student, we won't use dot, but we'll use predict student performance. And when we're calling it, we'll give it the actual number of hours studied that the user has inputted. Okay, and then inside this function, what you have to do is write code to make the prediction. And the reason we're converting it to int, you can also skip. If you want, you can skip this step. So this is just because when the user enters in the application that you saw, remember the application that I showed you on the first day? Yeah. So whatever you input, it's going to be string. But our model, it makes predictions on integers. So that's why I was asking you to convert these metrics to string, so to integers. So whatever the user inputs, it will automatically be converted to integer. Do you still don't understand? I don't mind explaining it again. If there's some specific part that you don't understand.
How do we have to put like values of these also are studied?
Not right. So this you're just defining the function. So this is very general. These values could be anything the user inputs. The user input part we'll do later when the user is inputting this. And basically, we'll store all the user inputs in different variables, and then we'll just pass those variables to this function. So it could be any number that the user inputs, and we will use that to make a prediction. Okay, let me just try to explain the entire, like the bigger picture and the flow of the program. So when you saw the program, what was it? It was um, hours, right? And then it was a blank. You had to enter a number here, right? And then it was previous scores, and then you had to enter a number here, right? So there were just fields, and then you had to enter something inside those fields. Okay, look here, everyone, especially Lakshant. Okay, so you had to enter some numbers, right? This was the program, and we're trying to make this. So keep this in mind. So what we're trying to do now is we'll get all the inputs of the users. Okay, that we haven't done that right now, but we'll do that. Okay, so we have to get all the inputs from the users, and then we have to basically give it to our model to predict a value, right? Is that understood? Right, so let's just break it down into steps. Now we have to get user input for all of these numbers, for all of these, then we have to convert them into integers, right? Because it's going to be in string, but our model understands only integers. So we just have to convert them into integers. Then we have to use a function. Okay, if a lot of you are not able to understand this, let me try to use a basic approach. Okay, so you just have to you have to use these values to make a prediction. Okay, leave the function for now. Leave the function for now, don't write anything inside. Use these values to make a prediction. So what's the first thing that you want to do? Get the user input, right? So just inside the main function, do you see a def main? So this is the function that will automatically run when you execute the program. Okay, so inside the main function, just just take the user input in a number of variables. For example, if it's ours, then do ours equals input, and then whatever you want to write here. For example, if you want to write enter number of hours studied, just write that. Sorry? Yeah, so what I'm saying is, let's do this step by step. Leave the function for now. You want to get user input, right? So you have to just get like inside, store the user input inside a variable for all of these metrics. Okay, so for hours, you'll get an input. For previous scores, you'll get an input. For extracurricular activities, you'll get an input, right? Just get an input inside the main function. So the main function is everything that will automatically happen when you start the program, right? So just do this. Do this for now. Yeah, are you able to understand how to get input? So in the last two classes, we actually discussed how to use like basic Python fundamentals, and we just brushed up on that. So the way to get a user input, like the syntax is just variable name wherever you want to store that input. For example, if I want to get the number, any random number from the user, and I want to store it in a variable called a, then I'll just do a equals input, and then I'll write give me a number. Okay, so this will be stored inside a. So like that, I'm asking you, you have to get the hours from the user, right? Because here there were like blanks, and you were getting values from the user. You were typing something, right? So that part we're doing. Input, get input from the user. Okay. Yeah, inside main function means here. After st.title, you have to write all of this, okay? Just after here. Sorry if the first part was a bit confusing. Do you get it now? That you just have to get the input. Are you sure? Okay, then do it quickly. Sorry? Yeah. So after sc.title, just write ours, like in the next line. I think you just missed a bracket. And this will not be indented like this. Just make sure there's no space here. So spaces are very critical in Python. Okay, because, yeah, just go to the next line now. Yeah, ours equals input, and then in brackets, just write, if you want to write type here, or give the number of hours, or enter the number of hours, whatever you want to write, in double quotation marks, because that's a string, right? Okay, did you get this? All of you? So now do this for all the metrics that we're going to get. Okay. Yeah. No, you don't have to run anything right now. Just go to the main function over here, and then go to the next line. So this you've done correctly. Very good. Okay. Now just go to the main function. After st.title, the next line. no, like this over here, the next line, right? Rs equals, you've done Rs A. Rs equals input, and then in brackets, and then inside whatever you want to write, like type here or give the scores. Okay, it has to be like the bracket also has to close. Just make sure you do that. And inside brackets, you have to write the string because this is a string that the user will see, right? So you have to write it in quotation marks. Okay, are you having any trouble? Do you understand why we're doing this? Okay, so this was supposed to be, okay, this was supposed to be after the title line. Okay, no worries. We will just copy paste this. Okay. And then inside title, whatever our title was, which was student performance prediction. So this is just the title of our page. Okay, let me show you something really cool. If you try to, let's try to run this. How to terminal works. The thing is, I don't use Spider normally, so I have no idea. Tools. Connect to an existing terminal. Debug run. How to open terminal in Spider. Under the menu item view. Oh yeah, this is correct. This is correct. Like this is exactly how it was supposed to be. Okay, just let me try to find menu item view. Panes. Do you see panes? Yeah. Do you see terminal somewhere? Terminal. Editor. Files. Yeah. Good morning. Wait. If you guys if you're done with this thing, then you can save all of your work and then you can leave. Okay. Um, it's not working. I can't see a terminal. This is really bad. Spider terminal. Okay, panes. This is Windows.